So just a refresh about what we have taken so far. Okay, so in your course, we started by the concept y equal f of x, right? And we said that the derivative would be the change in rate, which is in this case a y function x. So the derivative would be change in rate of y with respect to x. So that we call it y prime or we call it f prime. Okay, so this is the standard derivative. Now, then we have taken something called differential. So I am just refreshing, okay, all the concepts so far that we have taken. Then differential, we said we take only this part and we ask you to find dy. So dy would be, the x would jump right here. You have to say it's f prime dx. So all you have to do, just you derive as usual, but you put dx. And the x, these type of questions would be given as a value. So if you miss it, it would be wrong, okay? We passed by the concept of related rates. Related rates where time is involved. Okay, time is involved, okay, within the question. So for example, there's a point that is moving at a certain rate, let's say moving, let's say 3 centimeters or per minute or per hour, per month, whatever. All those denote time, okay? And in this case, whenever you have a letter name, when you derive it, because again, the derivative is just a rate, is a change in rate. So if you want to write it, I mean, this is change in rate, and that's it, okay? Change in rate. A rate of what? Of the letter name with respect to something, okay? So that's what we are going to do next. We will change the letter names, okay? Not necessarily y and x anymore. So related rates, still you have letter names, but you are related to time. So if you derive a letter name, it should be the x over dt. If there's a y, you derive it, you get dy over dt. Letters may change. It may be in a pressure, so dp over dt. It may be temperature, d big T over dt. You get it? So it will be given in the question itself, but you have not to be surprised. Okay. So far this question that we are going to deal with. Okay. So you don't have x. Okay, go ahead. So let's read it. So it's called Boyle's law. We don't care what law I mean. This is like just to have appreciation, okay, for the relation. Okay, so we have, they say temperature big T, they have pressure big P, okay? The relation they are talking about. So P over big T equals K. What is K? It says a constant. Now, why they made it clear? Because when you derive a constant, you get a zero, okay? Now keep on reading. Suppose the rate of change. So what is the 3 for? What shall I assign for the 3? Because you want to, what do I write for 3? It's rate of change of whom? Of the temperature. Now rate of change, it means derivative. So you see, it's written here. Rate of change means this. But what letter names you want to write? This is you have to know. Yeah, can you guess? Yeah, what letter names should assign to 3? So it says it is a 3. Right here, up and down.
dt over dx.
Yeah, dt over
dx.
dx. Okay, well, you are talking about x. There's no single x right here, even because in a question they would define x to be, for example, the quantity, demand, something. Okay, now do you see any x there? That doesn't make sense. You don't see. You see only a p and a t. But this is the trick. You should get a hint. You see, it says per hour. You know that the word per means a division, and the hour would be here, okay? So it's clear that this is 3 degrees. So this is degrees per, so this is dt over what it denotes. Any idea? This what denotes? Like a minute, seconds, months, all this denote time. That's what we are talking about. So you should put d small t.
Okay.
Small t. T denotes time. Okay. Now the 3, if you want to write what this stands for the degrees per hour. 3 degrees per hour. And that's it. This is the unit. Okay. Now keep on reading. It says, the question is, want to find the rate of change of pressure. So this means d over dt. How much? Okay, now there's some numbers given. It says big T is 250 and big P is 500. Okay, capital letters. So It's given at or when, okay? You want to evaluate this pressure with respect to time, the rate of change, when the temperature is this. I'm just interpreting. Okay, we didn't solve yet, okay? Any questions so far?
No.
Perfect. Okay, so you are supposed, to review at the end of the session this question, because on your own you should figure out all what I have written, okay? And because this question may be changed, okay, they give you a different name. It's like some other relation even. Letters may change for sure, a different relation. Anyhow, so how do I solve? I would start by what is the relation given in P and T. So let me rewrite again. So I would say given a pressure over time equals constant. Now, what shall I do? I should find dP over dt. I don't see it. What do I do to get this look? I should derive. I would say derivative, okay? Apply derivative on both sides. Apply derivative or derivate on both sides. You agree? Now, if I apply derivative, be careful. K is a constant, but P and T are not. So this is quotient rule.
Why are we deriving this?
Because the rate of change. How do you find rate of change? We want to derive. Rate of change means derivative. Okay, this is rate of change. The rate of change of the pressure with respect to time is derivatives. What do you mean by dP over dt? It's the derivative of P, but this is related to time. Okay.
Okay.
I want to apply derivative, but the idea is if you want to apply derivative, the look that you have is not easy. This is, you have to use, this means use quotient rule. Now to avoid quotient rule, quotient rule is long, which is U prime V minus over V square. Okay, we call the up a U and the bottom a V. So I want to avoid it. I want to avoid this, avoid. So change the look, P over big T equal K. Simply, if you cross multiply, how much would be big P? I'm changing the look, okay, only KT. You agree? So do you have a quotient rule anymore?
No.
No quotient rule anymore. Do you have a product rule?
Yeah.
No, we don't have product, although there's a product. You know why? Because this is constant. Product rule when you have two-letter names that they are variables. Now K, okay, K, they said a constant, although you don't see it a number, but it's constant. Okay, now maybe this is first time you see this type of questions, but this is how it goes. Okay? Do you have any questions so far? So I want to say no quotient rule, no product rule, which is direct derivative and which is so easy. Now students who are not, let's say, aware of this process, wow, they would take much more time. They would fall in mistakes because the way you write the derivative is not easy at all. And I can show it to you. But you can expect what's going on because the way you want to write derivative is not like simply U prime or P prime, or there's nothing like P prime here. The derivative here is not a P prime. You get 0. T prime doesn't exist in this context because that look of the derivative. Imagine you want to write all these forms. Anyhow, to make long story short. So I would start deriving P equal KT. So you say derivate. If you derivate on both sides, what do you get? Go ahead.
How can we do it if it's just letters though?
Okay, I would remind you when we said y equal 3x squared, for example. So this is a letter. We say y prime equals 6x.
So P prime?
Okay, P prime equals
K prime, T prime?
No, we said K is not a variable to derive it. K is a constant.
Just T prime.
It's like the K. This is 3 is like the K. You then derive, you keep it, the 2 goes to the front. So this is K, T prime. Okay?
Yeah.
Good. But as we said, you didn't realize that you will get a 0 if you write it. This is 0 answer. But I'm just following you. And it's the way we learn is your mistake, you avoid it in the exam. This is a 0 answer. It's wrong.
Doesn't K become a 0?
Okay, K plus T. If you derive K, this is 0. if there's a plus or a minus, but when there's a times or division, the derivative of the k is not a zero. So I want to say, okay, remind, when you derive, when y equals 3 over 8x, so what is your derivative? Do you say this is a zero? No, because it's under times 3 over 8. But if y equals 3 over 8 minus x, the derivative of this would be a 0 minus 1, yes. Okay?
Yeah.
Okay, I'm just because you missed a session or two. So it seems that you forgot all those. Anyhow, so why is this a zero answer? Because we said there's time involved. Time doesn't show in your answer. Time involved, okay? You cannot write those. This means, by the way, it's derivative of P with respect to T. This means derivative of P with respect to temperature. Okay? And this means you are, yeah, but that doesn't mean any sense. This means derivative of T with respect to T. So it's wrong. Okay? Zero answer, time involved. So we would continue again. P equals KT if you derive it in this context. So the derivative, I want to write the derivative in this context, or derivative in related rate in relation to time, the derivative in relation to time, because there's involved in the question. Then derivative would be in the slope, small t. We said this is a times. We don't derive the constant, we keep it. Under times it stays. Okay, now deriving this should be d big. You don't care for just copy the letter name, but there's small t. This is your answer. Now you should replace numbers. Easy to replace numbers. How much is the rate of temperature changing? We said it's a 3, you see, at the beginning. So you put 3. Okay, this is a 3. Now how much is k? Okay, still to find k, how much is k? But you say, but k equals, but p over t equals k from the beginning. You still see the question at the beginning.
Yeah.
Okay, you see, p over t equal k. So I can find k. How much is p?
500.
Yeah, put those numbers. How much do you get? So, yeah, use calculator. So it would be 500 over 250, is it?
Yeah.
Okay.
2.
Okay, so it is a 2. So your final answer, P over dt, simply would be 2 times 3, which is a 6.
Yeah.
Okay. Go to the question, be careful to get full mark. What is the rate of change of pressure? So it's a statement, okay, you want to write. When they didn't say, okay, find the rate of change. Find, okay, it would be 6. But what is the rate of change of pressure? Write your answer in a statement. If you don't write it and your professor is tough, okay, serious, he won't give you full mark if you stop right here. First of all, the units you didn't write. You didn't say 6 what? And you didn't mention what does that 6 mean. So we want to say the rate of change. Now you can put it the way you like, but I prefer we say this, the pressure, because that statement we use to in all our answers. The pressure is, we write something here, at a rate of, we write something here, and you put the units. What units we have? This is pressure, right? Now, if I give you the unit of pressure, you say units, okay? Now, this is degrees temperature, but the pressure, I don't see its unit somewhere, okay? They didn't say a name, so you say units per, okay, per what? Per hour, because time here is in hours. Okay, units. Whenever a measurement is not given, you put it units, okay? Per, you can write it in words, or you can just put it as a slash per hour. Abbreviated, or you can write in hours. Now, can you fill what goes in these blanks? Wasn't these blanks? The pressure is what? Is
6.
Sorry?
6.
No, you forgot, by the way. You should make revision, okay? Your exam in 2 weeks, okay? So be careful. This has to do with the plus. How do we put the plus? Just remember, minus decrease plus. Plus means?
Positive.
No, we said minus, we say decrease, the word decrease.
Increasing.
Increase, okay. So that you should, in this context, okay? In this context. Because you should write the meaning of this 6. It's a rate, it designates a rate. So the pressure is increasing at a rate of 6 units per hour. That's it. This is a complete answer. Okay, this is a complete answer. Mark. Now, as much as you don't try the full answer, you take partial marks. So students who don't try this, still the 6 is correct, they don't take full mark. Okay, but be careful, if you miss again this look, you get a 0 right away because the context of the question should be in T. Anyway, so that we are studying because you want to be aware of such a problem in case it pops in a test. Okay? Yeah, we'll take more anyhow, similar. Let me see. Okay. So I'm picking the question from my data quests. Let me see. Now we have taken a point is moving that you should do. Okay, this I keep. Okay, now we want to take a question we said about tangent, and at the same time, yeah, we have the concept of yeah, different forms of derivatives as well. Okay, yeah. So we are on the lesson or the skills that has to do with the equation. Now you see there's an S here. It means you may have more than an equation. You may have more. We don't know. Okay, so find the equation. So don't be surprised if you have 2. Now in your course, you will get maximum of 2, maybe. Find the equation of the tangent line or lines to this graph at a given, usually this would be a point or a value. So they made it hard or harder than usual because they didn't give you a point. They gave you only one value. Okay, so I want to get a feedback from your side. What can you do in this question?
I don't know. We didn't do questions like this.
Perfect. Okay, good. Now, we jump right away to answer the question. Okay, so when they say find the equation of the tangent, right away I would say equation of the tangent. What is the equation of a tangent line? Now, equation of the tangent line is a line at the end. Okay, so what is the equation of tangent of a line? Okay, it is y equal mx plus b, simply. This is the equation of any line. Now, what is the m? We call the m slope. I will call the b y-intercept, but that I don't care now, okay? So what is the slope? Because step 1, you find the slope, then you find the b next. So find the slope. Now, it turns out that by theory, that the slope of the tangent line is the same as the derivative. You see, we are back to derivatives. It's the same as the derivative of what? Of the given graph. They call it a graph or a curve or a function. You don't care, okay? So this is the derivative of what is given right here. The derivative of the given graph or curve, okay? The given curve, or they call it a graph. Is it okay?
Yeah.
So the background. Now, when you do the derivative, you'll get x and y something. So those are in letters. So what they gave you because you want to get your slope in numbers, okay? So let us see what's going on in the problem. You have many surprises. So what is step 1? So step 1, I should find the derivative of the given. So what is given? Let's write y minus. Okay, go ahead. Derive. Now, I remind you, this is implicit derivation because the derivative in this look, you derive every term. You derive every term. You derive every term you see.
Would it be y prime?
Yes, so this is y prime minus open bracket. Why I did open a bracket? Because your answer is not only one term here. Okay, so
y prime.
Apply product rule because x and the y are letters. So this is u and the v. So your answer here would be u prime v plus v prime u scenario. Okay, can you fill in? What is the derivative of the x? Is a 1. Derivative of the y squared 2y y prime. That's it. We are done with u prime v plus. What is the derivative of the y squared? No, sorry, we shouldn't derive the v. So repeat again. U prime is only 1 times y squared. V prime is the one I'm talking about, 2y y prime, because you're deriving y squared. Okay, times how much?
Y prime.
Times u. What is u?
U is x.
X times x. Okay, that's it. Where are we in the derivative now? Where are we? So we did the derivative of this. We did for that. So now we want to derive x squared. How much would be?
2x.
2x. Deriving the one in
0.
0. And derivative. So imagine this is 100. You should derive it. So what do you get? You get a 0. So be careful. It's not like now they gave you 0. I don't know why they gave it this way. Okay, but maybe to have simple numbers when we solve for y next. Anyhow. So this is the derivative. Any question? Now this is complicated because x is given as a number. Go ahead, replace. X is 1. Now you're supposed to have x and y to replace. But where's okay? So if you replace x, but you see there are y's. So what is the y value? You see, you should expect always given a point or two values, x and y. So you should put a question mark. Okay, if I put x1. I still have y's, I don't know. So what do you do to find y?
Take y out as a common factor.
No. You should find y prime, and I mean y prime is your question, but within your calculation, y is not given. I mean you have to. You get it? Okay. The main thing that you want to find here is y prime. I want to find this, by the way, and that. But y is not there. How do I solve y prime and y is not a number? You see? You say y is not given. I'm explaining. So what you do is, it's not given, it is hidden, by the way. It's not given clear, but it is hidden. So you have to get it. What do you do to get it? You go back to the given equation and you find y from top. But you put x equal how much? How much is x?
1.
Okay, so let's do it then. I want to copy the equation to the. So this is this question demands many steps. So be careful. Okay. So I want to put the question to the front in order to continue. Okay. So you come on right here. Okay, it is hidden, but we say replace. Sure, replace. So x is a 1. So this is a y. X is a 1, so it becomes y squared. X is a 1. Okay, so solve it, find y. Now you know that this is quadratic. You can just put it in order. So y squared comes first, then the y comes next, and this is plus 2.
But what happened to... Oh, okay.
Okay, we are replacing. This is a y here.
We replace it into the original equation?
Yeah, original. I copied from the top.
Okay.
The original, okay? Okay, now, how do you solve it? You have two ways. Either you factor it, I mean, if you are good in factoring, you do so, or you do the quadratic formula, okay? That's it. So, which follow? We'll do quadratic formula, okay? So, y equals, you'll get the answer using calculator.
Okay.
Okay, but tell me what is A, B, and C now? How much is A, B, and C?
A is -1. B is 1 and C is 2.
Okay, good. So I would replace you, use your calculator to find out. Good. Remember, like we take once a plus and then another time a minus. Okay, we do it 2 times. So B squared would be 1 minus 4A is a minus times C. Over 2A means 2 times minus 1. Now we can put it all on calculator, but because I'm explaining, so I wanna till you get an answer, I wanna write what's going on. So plus A.
Minus 1 and 2.
Okay, good. So here we got minus radical 9 is a 3. Yeah, so it's a minus 1
And
a 2. Perfect. Okay, what, by the way, those are for what? For y. You agree? So let me write. Y is a minus 1, and another time y is a 2. What does that mean? For that reason, how many equations do you get? Depends on how many y's do we have. So for that reason, we have 2 equations. So what they expect you to do, you want to split your page into 2. Okay, you do calculate here for this value, and you do the same thing, but for that value, so you'll get 2 answers. For that reason, if you go up to back to the question, you see they ask that you may have equations, not only one. Okay, you see, find equations of the line. Is it good? So this is your equation, by the way, but I said we need derivatives. You want to go back. Where we stopped, by the way, where did we stop? We stopped right here. We stopped right here. So I want to copy it. Okay, and then I want to replace how much is x and how much is y do we have. So far, so good?
Yeah.
Let me see if I can shrink it to that part. Yeah, anyhow, so I want to say, now this is for explanation, okay. So y equals to now, okay, I want to take all this away. Okay. I want to replace, so keep in mind x is a 1, we got, now we are doing y equal minus 1. Now we are doing for y equal minus 1. X is a 1. Go ahead. Y prime, we don't know, we keep it. Minus open bracket. You put a y minus underscore, you get it 1. Okay, so 2 bracket minus 1, y prime, x is a 1. I'm replacing x is a 1, so you get the 2 equals 0. Is it good?
Yeah.
Okay. Now you see this bracket. Let's find out what is in that. I mean, you can do calculation the way you like, but I am just clarifying in steps. Okay. So this is, you don't add. You cannot add because this is all multiplied together. So minus 2 y there's a 1. Because some students will go on adding. Be careful. Okay. You cannot add because multiplication is stronger. Okay. I mean, when you have 1 plus 2x, can you say this is 3x? Okay, no way. You cannot add 1 plus 2. Be careful, right? So for that reason, this you should find first. Yep, go ahead, find y prime. I should take away the bracket. So this would be y prime minus 1 plus. How many y primes do I have?
2.
The 1, kick it, you get minus 1. So y prime is minus 1/3. Any question?
No.
Perfect. So far. Okay, so if y prime is minus 1/3, so this is m. Now you say the first equation, we have first and second. The first equation of, or the first tangent line would be what? Would be y equal mx plus b. Now we have m, okay? But you expect to get b, so there's a question mark. What is b? We don't know. So what do? Is you replace y and x that you are doing or working in, while working in this, later want to work in that.
1 and minus 1.
Yeah, so let's replace to find b. You see, there are many steps. So x is a 1, but m is this times y is a, how much y? Minus 1, we said, yeah. Plus b. Use calculator to figure out.
It's
I mean,
like
if you kick this...
over 3.
1 plus 1/3, you get?
Minus 2/3.
Minus 2/3. Okay, that's it. So you put a conclusion, you are done with the first equation. You say y equal minus 1/3 x, and the b is minus 2/3. Finish. Now the second one is related to the second y, which is 2. So now we say for y equal 2, okay, we have this means we get, I'm explaining, okay, now you want to write it the way you like in the exam. For y equal 2, we get the second tangent line. And I'm writing in every time different way of, okay, you can choose which way you like. We get the second tangent line. Okay, now remind y equal 2, x equal 1. But that should be replaced in the derivative. So you go back, you take the relation that has to do with the derivative, you come back to this. And you continue evaluating how much is your derivative. Go ahead.
So 2 squared.
So you're going to put y2 and x1. So y prime stays, open a bracket. Y squared means a 4. If you want to calculate right away, 2 times y is a 4. 2 times x is a 1. So it's a 4y prime. Okay? X is a 1, so 2 times 1 you get 2 equals 0. Any question?
No.
Now you evaluate unless you remove the brackets. So go ahead. Y prime minus minus plus 2 equals 0. Okay, numbers can be calculated. So this 1 minus 4 you get, and minus 4 plus 2 is minus 2. So you can kick this. I mean, you want to move faster, it's up to you. There are students who can right away from here put the answer. I mean, there's no question about it. So y prime is minus 2/3. In the first, we got different minus 1/3. Okay. What is still to find? So you say the equation, the second equation, in fact, y equal. So again, b is missing, but I want to put y how much in this case? Y is a 2, right?
Yeah.
So you put y2, and you want to put the m, this is m, the minus 2/3, and the x is a 1 in this case, plus b. You kick this, use calculator. So b is 2/3, 8/3. Do you agree?
Yeah.
Okay, that's it. So the equation is, and the equation should be in y and x. So you replace m, and the b is 8/3. I am done. Now it's long. It's long, and yeah, it demands, I mean, attention. It's not hard, but it's long. Okay. Now that came in the midterm, so be careful. Okay, good.
Yeah.
Wait. Type. No, that is done. So the equation of tangents are done. Finish. Now I wanna approach a kind of derivative. So the concept is explained by the letter, but it is tricky. Okay, we finished. By the way, the lessons required for midterm are done. Finish. Now this is the last thing that you have to know, I guess. Okay. Let's some problems pop here and there, like related to some concepts, but so far, this is about derivation again.
Mm-hmm.
Let me see if you're able to do. But I wanna put a different, different and see the difference. Okay. So this is another question. Same. We say same category, related to same category. But I want to let you see the tricks in between these questions, okay? And see the difference, if you can figure out. Yeah, can you figure out what should you do in these problems? Okay, I want to put one more question. I'm not asking you how to solve it. I'm asking you just if you can figure out the way the question is different or in each. So in this type, does it differ from this and the one after? And what is the difference? There's the way it is written is completely different, okay?
Yeah.
Now you notice here it's x bracket t. Now this is t bracket x. That needs a, because students, I mean, now average, by the way, average students who don't understand what's going on, average, I'm saying, and even below students, I mean, those are very weak, so I'm not talking about. But average students, this confuses average students because they see here x of t. If they solve this problem and they understood it, they go to the exam and they see t of x. You get it? Now it's completely the opposite, by the way. If you understand this and you don't grasp it properly, for sure you won't get the one before. Or if you solve this problem and you get that problem because this is reversed, then for sure you would make a mistake. For that reason, these are, I mean, they are opposites. Okay, now all those are the same. They ask you, but be careful. Like right here, there's something given which is not there. I mean, this is t and x, but that is not clear. This is even. And so what is the hardest problem, by the way? This is the hardest problem. This is the hardest among these two. You know why? Because it's not clear what to do at all. Now here they say find x prime, find x prime. Okay, perfect. Now here they say calculate the slope. Wow. What is the slope? The slope turns out to be the derivative, but derivative of whom? But this is clear. That is not clear at all. First of all, students who don't know that they should do derivative, they are lost. And derivative of what? You should decide. So, which one we should do first is the easy one. Easiest is this. This is the easiest. Tx is clear. This point is not clear. You should know. Perfect. So we'll start by number 6, which is right here, the easiest. We'll start by this one. Okay? Are you ready? So I didn't explain how we solve it, but I was just scrolling among the questions to see, let's say, the difference in between. Now, when you understand the concept, let's say, that is behind these questions, okay, it would be clear and easy. Okay? Are you ready?
Yeah.
Okay. Okay, first of all, I want to get a feedback on your side. What do you do? This is given. I guess it's clear, but let me write it properly in like bigger font. So I'm copying the relation. And they say find x prime. Go ahead, please, find x prime. Get something from your side to figure out where's your trouble. For sure, I would explain in details. I want to see where are you now? Where do you stand?
So now I have to derive?
Yes, but the derivative is x prime. They need x prime. Okay, derive, go ahead. So I want to see. No, you have a few seconds, okay? You don't get it, it's okay. You want to learn it for sure. So
ln x is a 1 over x.
Derivative of 1 over x, okay, good. Derivative of the x is the one we know. Derivative of et, what? Derivative of t, this one. Okay, what else? Derivative of et. Derivative of the one is?
0.
Okay, good. So where's x prime, by the way? Where's x prime in the problem? If there is no x prime popping, I mean, what is it that you want to find? It's on there, how it comes. Where's x prime? Yeah. Well, you know, this is implicit derivation. I mean, when you derive, so this is the background. There's nothing new, by the way. We have taken this. So I want to ask you, be careful when we say when y a function x, y is a function x, then what is the derivative of y? You say y prime. What is the derivative of y cubed? How much would be?
It would
that we learned 3y squared times y prime. So what does it mean? It means when this is a function of the one that is the one in the bracket, we say is in the, it depends on. I mean, this is the theory. But if you don't want to go with the theory and you don't want to understand all the stuff, we say y depends on x. For that reason, when you derive it, then the derivative is attached to that letter name. But if I ask you derive x cubed in this context, be careful. Those, okay, those are related to what's given. When this, when I ask you derive x cubed, what do you say? You say 3x squared. There is nothing like x prime here. You agree? Because x is independent, we say. Or if you want to understand it in a different way, because x in the bracket right here, it means the basic variable. Y depends on x. So by the way, this one, y equal f of x, can be written as x, because I want to give you what does that mean. You get it? I want to just introduce you to this look. What does that mean? So when I say x bracket t, what does that mean? X is like the y. Finish. And that's, you get it? It's the same look when I am talking about y bracket x. So if this is y bracket x, is like x like the y, t like the x.
Yeah.
What does it mean? It means the same thing I am doing here, I would do there. So when I want to derive the letter name, it should be out of the bracket. The one in the bracket, we don't derive it. We derive it, there's no popping, because the derivative of the x in this case has no symbol like x prime. Is it okay? Why I'm explaining in a different language. Now, this is not the proper language, okay? Just to make it, let's say, easy for you to grasp. But anyhow, another example. When I say, for example, this is the whole trick. When I say, when x, a function in t, this is what I meant, x bracket. So when I derive the derivative right here, do you know the derivative pops x prime, but not t. So this is what you want to know. When t a bracket x, what does that mean? It means t a function in x. You get it? So the derivative that you want to do right here, the derivative pops what? When you do the derivative, it pops
T prime.
t prime, not x prime. You understood? Yeah. Because why this is why? So simply you go back to the standard. Because why? Because y a function x that you know. Those are we are not acquainted to, but it's required in the course. So they change letter. Students, they face difficulty in this. Okay. So when they change letter names other than y and x, students are lost. So why? Because y a function in x, we write it this way. And when I derive, this means the derivative is not x prime in this case, is what? Derivative is what is? What is the derivative of this look?
Y prime.
Is y prime and not x prime. Okay, so I have a student who said, okay, I don't want to understand all this. I have students who don't want to understand all this background. And they say, whenever I see that bracket symbol, it means a function, blah, blah, blah. I understand, okay, I understand all this, but I would derive the letter name which is outside, and that's it. Okay? And not only this, by the way, there's still the point. When a point is given, there's a trick. When a point is given in y equal f of x, when I say y equal f of x, and the point is given, what is the look of the point? It's x comma y. Do you agree?
Yeah.
What does that mean? It means y equal f of x means the look y bracket x. So what does it mean? It means the point is designed that this comes here, that comes there. Do you agree?
Yeah.
This is a fact. Now, given t bracket x. So the point, how is the point now designed? What shall I put here? Is it tx or xt? No, I don't have y. You get it? So what do? You do this. I mean, the point would be same way as I am doing there. So this x comes there, this t comes here. Okay, let's say given x bracket t, as x is a function of t. So what is the point then? What do you put first?
No, t.
T, then x.
Yeah.
Okay, perfect. This is what you want to understand. Okay, good. So I explained how the point should be, and I explained how do you do derive. Perfect. Because if you go back, this is what they are testing you in. You see, they gave you the point, but I don't know which one is a t, which one is an x. If you pick this wrong way, I mean, you are lost. You'll get a 0. You get it? Now, this is the easiest. Why it is the easiest? Because they say what to find and they say what is the point. But by the way, they are not said wrong because x bracket t, what is your point? What is the point designed? How is it designed? It is designed t here and x there. So yeah, they didn't say something wrong, but they made it easy for students. They made it clear. You get it? Here, they didn't say. Students are confused. Well, they know that x always first. Well, now here it would be wrong because x bracket t comes first in this case. It's not x. Okay? And right here, same thing. Which one comes first? You should decide. Which one to derive? You should decide.
Yeah.
Good. Now we have a few minutes. But anyhow, I will give 5 minutes more because we wasted time and some problems. Okay, so let's derive the problem. Now, the way you derive right here is completely wrong, and you would figure out why. So this is completely wrong, okay? Because you see, there's no derivative to find. There's no x prime popping in your answer. Where's x prime that you want to find? So let's redo again, because now I guess you're able to solve. So let me repost the question again. Yeah. Okay, so it says again, find x prime. Now the point is clear. Okay, so let me rewrite what. Okay, now I want to ask you first. When we did, by the way, the problem before in the equation of the tangent, now this is not about t and x, it was about y and x. Do you agree? We wrote too many. Okay. Because if you understood that problem, you are able to proceed with the current question. I am asking, this is a standard graph, y and x, not t and x or something else. Okay, so, and we know that always we are deriving, so it's y prime. We know it's by default y equal to function x. But my question is, when we reached x squared, how did we derive it? How did we derive xy squared?
We did the product rule.
So, why did we did this? Because you have two letter names and y a function x. What does it mean? Because y depends on x. I mean, when you have the two letter names in the function, under product, you should do product rule. Okay, so if you, do we have this scenario here, yes or no? Now, x a function in t, right?
Yeah.
Like y and x. So we have the two letter names under times. So, product rule, if you are not aware of it, you'll get a 0 for sure, okay? If you don't derive it the way it should be product rule, you are lost. So this is a u, that is a v. And the product rule now, it's u prime v plus v prime u. And here, by the way, do we have a product or no? We have a product.
It's being
Product in between x and t, yeah? So we have, in this question, we have two product rules. We have product rule, so not to copy it again. We have product rule here, and we have product rule there. Is it okay? Are you able to solve it now?
Mm.
But you want to keep in mind that anytime you approach the letter x, you want to derive it, x prime pops. You don't pop t prime in this context. Be careful. Okay, we are talking about a certain application that has to do with letter names of functions. This is a context of questions. So I'm asking you, do I have time related here? Do I have time? I mean, do I derive like the x over the t? No, you see, there's no time involved, you get it? So the question is, be aware of what the context is. In this problem, x prime should pop, finish. Okay? So, I'm going to derive it. Go ahead. What shall I put? Deriving t is how much? So u prime v plus v prime u. What do you write?
1 into...
Yeah, 1 times ln x plus
1 over xt.
Okay, but you missed. Anytime you derive the letter x, x prime should pop. So there's x prime missing. It's x prime. Because I want to remind you, when you derive ln a, it's a prime over a. That way I have taken, okay? So there's the derivative you put out. Okay.
Is it the same as 1? 1 over x?
Yeah, it's 1 over x times t times x prime. So x prime, I prefer to write it this way. I mean, I won't write this derivative like 1 over a times a. It's like made up of 2 parts. I prefer to write it 1 part, okay? So this is true. It's 1 over a times a prime, but it's better to write it 1 fraction.
Okay.
So x prime over x times t is your derivative. Okay, we are done. Now let's derive the other part. Continue.
1 times e power t.
1 times e power t. Now you missed again. You take a 0 if you miss it, okay?
Oh,
You missed what?
Prime.
You missed x. Yeah, it's 1 x prime. So yeah, the derivative of the x is your 1, good, but because the context asks you to find x prime, if you miss it, so it's incorrect. So you say 1x prime times e power t.
Yeah.
Now you don't want to write the 1 is okay, but I am explaining. Now this is u prime v plus et times x. That's it. Okay, correct. Deriving the 1 is a 0 finish. Okay, you see, is it simple problem? Well, it is simple, by the way, because I said again, because x prime is clear that you want to find, the point is clear that you want to do, but again, it's not easy if you don't know how to derive. Okay?
Yeah.
I mean, this is how, teachers determine the level of students, because there are 3 levels right here going on. Perfect. This is the way they determine which one knows, which one they don't know.
Yeah.
Okay, anyhow, so now it's time to replace numbers. Okay, you don't have now replace numbers. So you see how much is t there, by the way? X is how much? It's given here, how much? Sorry? How do you read it? T is the first number. It's first number, okay? This is the way you read it. T is how much?
0.
0. X is?
1.
Okay, good. So T0, X1. I want to replace it blindly, okay? And then you do your calculator evaluation, okay? So T is 0, blindly, X is 1. So this would be ln 1. X prime has no value, we want to find, okay? X is 1, T is 0, okay? Blindly, I am replacing. Be careful, X prime, we don't know. E power 0 plus e power 0 times 1. Any question? Because I have students who make even a mistake. Those are very weak students who say X prime is like, they put 1 prime. Whoa, it's out of the planet, okay? So be careful. Is find X prime, you don't touch it. X is not the X that you see here. This is X prime, the change in rate of X with respect to T. This is what we meant by X prime. The T is the T there, okay? It's not the time we are talking about even. Okay, are you following?
Yeah.
Okay, go ahead now. Your job is to find out, I mean, ln 1 on your calculator is a 0. Okay, so this is a 0. By the way, this is a 0 again. Okay, they made it easy. Now, e power 0 is a 1, so you get x prime. E power 0 is a 1. So how much is x prime? With e power 1, you get minus 1. That's it. This is your answer.
Okay.
This is exactly your answer. The derivative is minus 1. Any question?
No.
Shall we do the next problem that I posted here? Yeah, so the minus 2 and the 1. You can do it?
Okay.
The minus 2 and the 1.
Okay.
Yeah, go ahead.
So if they don't tell us Tx is this and that, we know
You should know. You should know. And we explained how do we know. Okay.
Okay.
Yeah, so the numbers stand for letter names, but you should know how to figure out.
Okay.
So let me post again the question here. Okay. So let's decide, by the way. So it's x bracket t. So let me write it x bracket t. So this value is 4 and this value is 4. Okay? That we can. So we can write x is how much, t is how much. Is it okay?
Yeah.
And x prime. So, but be careful if you have a product. So be careful. I mean, you scan the question, figure out what is it that you should clarify. So this is product rule. Because if you start deriving and you are not over, this is a product rule, you get a 0. Okay. Anyhow, now let's solve. Deriving this.
This would be 2x prime.
Perfect, okay. If there's a minus, I put minus.
And then product rule.
Why? Because I have many stuff here, and this minus would be in later.
So 2t.
So we are doing u prime v prime u. Yeah, it's a 2t times x plus
x prime
times t square. Okay, good. Finish. Deriving time on that level now. Deriving of t cube is
3t squared.
Okay, good. The 11 would be 0. I'm clarifying, but no need to write it. Okay. Now be careful. That if it is 100, the rate of this is a 0 again. So don't write 100, because I have students who write it 100. They forgot. You should derive here again. Okay.
Okay.
Anyhow, so we can put numbers now.
Okay.
Replace numbers right away. Replace. X equal 1, t equal minus 2. Go on. You replace it blindly. Okay. So let's.
It's going to be 2x prime.
So 2x prime minus open bracket. T is a minus 2, you get minus 4x. T square means a 4. Okay. T square is a 4 times 3, you get a 12. Okay.
Why did we put the 1 in x?
Yeah, the x is a 1. So 2t, yeah, 2t minus 4. 1, no x. Perfect. Now, remove the brackets. So we get plus 4 minus plus 12 equals 0. Okay, you add those up. 4 and 12 is 16. You get minus 16. You kick it. Okay, because we want to isolate x prime. But by minus 2, you get it 8. Is it okay?
Yeah.
So that is your answer.
Okay, I got it.
Okay, so no worry, we'll solve the last problem and we are done. The last problem we said it's the hardest, but it's only they say. So just you want to derive, okay? So let's do this and we are done.
Okay.
Okay, go ahead. Now that you need to explain a little. So because t bracket x, so the point comes on e comma 1. So which one is e? Which one is this value? Is it for whom? For? Yeah, do the arrows, I mean. What do you write?
That one is t. No, that one's x.
Yeah, you go this way. Huh? You go this way. Anyhow, so x is an e, t is a 1. So that I assign. Now, when they say the slope, it means derivative. You get? I'm analyzing. What is it? Okay. It's derivative, but derivative, is it t prime, I'm asking, or is it x prime? I'm asking you. Is it t prime or x prime? How do we realize? We said, if you go back to the standard, y function x, this is the way we write y function x. So this is y prime. You take the letter out of the bracket. So it should be, sorry?
T prime.
T prime, okay, good. So let's start. By the way, they gave you easy looking function. I don't have product rule. You don't have product rule, okay? Because they hide many stuff. So they said, okay, let's take it easy in one question, one students. So, so when you want to find t prime, anytime you pass by the letter t, so t prime pops. It pops. So deriving et is et times t prime. Because you are about t prime, not x prime, okay? Oh, no, deriving 3t is how much?
It would be 3t prime.
Perfect. Deriving x is how much? So it's the one here. That's it. Deriving 3 is how much? 0.
0.
Perfect. Good. Okay. Now we replace numbers. Let's replace. And so x is how much? E. I don't have x in the answer, by the way. It's all t equal 1. So this is e times t prime plus 3t prime. Let's kick this equal 1. Okay. So they made it easy graph or easy curve or easy relation. Okay. Anyhow, so how much is t prime, by the way? You cannot add those, but you can take t prime as a factor. When you cannot add, you take as a factor. So the end. How much is t prime then? What?
1 over e plus 3.
Okay, good. 1 over this. Perfect. That's it. So this is the slope. Okay.
Yeah, good.
Okay, so we are done. Yeah, see you next week, and then we'll start making revision. Otherwise, I mean, make summary of those tricky questions. How do you figure out what we were doing?
Okay.
Perfect.
Okay. See you.